In this video, we're going to discuss logarithms. Specifically, we're going to give a formal definition for a logarithm and look at how to convert between logarithmic form and exponential form, which is one of the most useful things to do when working with logarithms. We'll start by indicating what exactly a logarithm is and how we want to think about it in order to use it appropriately. Informally, logarithms are simply exponents. This is worth keeping in mind whenever we talk about logarithms, that what we're really doing is looking for a specific exponent that has a particular property. More formally, the logarithm base b of a number x is equal to y means that the number b raised to the y power is equal to x. In other words, the logarithm base b of a number x is the exponent by which we must raise b2 to get that number x. These two expressions both indicate the same thing. They both indicate that b raised to the y power equals x. The first expression listed is called the logarithmic form of the equation because it's written in terms of a logarithm. And the one on the right is called the exponential form because it is written in terms of an exponential function b to the y. And so a lot of logarithm problems and a lot of issues with logarithms can be dealt with by converting from one of these forms to the other. But before we do any particular examples with this, there are a few notes that are in order. Some things that we can see from just this definition that's worth making note of now before we start doing anything with logarithms. The first thing to note is that the base b of the logarithm must be a positive number. And that is clear because in the exponential form, the base b is the base of the exponential, and bases of exponentials are always positive. Right? We also cannot have b equal to 1 because, again, an exponential with base 1 is not an exponential form. So we need b to be positive and not equal to 1 in both of exponential and logarithmic form of this particular equation. Also, and perhaps more importantly, notice that the number x must also be positive. Again, we can see this from the exponential form. X is equal to the positive number b raised to an exponent y, and regardless of the value of y, a positive number raised to any power will always be a positive number. And since that number is equal to x here, we have to conclude that x is a positive number. So the only values we can take the logarithm of are positive real numbers. So let's take a look at a couple examples converting between logarithmic form and exponential form of an equation, which is one of the big tools that we'll use when dealing with logarithms. In this example, we want to convert the logarithmic expressions to exponential form. The first thing we need to do is to identify the three values in our logarithmic expression. For our first one, we have the log base 6 of the square root of 6 equals 1/2. Our base here is 6. The number that we're taking the logarithm of is square root of 6, and the value that the log is equal to is 1/2. And so when we go to convert this to exponential form, we will take the base, which is 6, raise it to the value of the logarithm, which is 1/2, and set this equal to the value we're taking the logarithm of, which is square root of 6. So the exponential form of log base 6 of square root 6 equals 1/2 is 6 to the 1/2 equals square root 6. This is something that we know is true, that writing the square root of a number as the 1/2 exponent is a property of exponents. So this is a true statement. For part B, we have the log base 3 of 9 equals 2. In this form, we have a base of 3. We're taking the logarithm of the number 9, and the logarithm is equal to the number 2. And so converting to exponential form, we take our base 3, raise it to the value of the log, which is 2, and that's going to equal the value we're taking the logarithm of, which is 9. So log base 3 of 9 equals 2. in exponential form is 3 squared equals 9. In this example, we want to do the exact opposite of what we did in the previous example. We want to convert these exponential forms to logarithmic forms. Again, we're going to use the same correspondence that we used, just in the opposite direction. For part A, we want to convert 2 cubed equals 8. So this has a base of 2, an exponent of 3, and a value of 8. And so when we convert this to logarithmic form, we're going to have the logarithm base 2 of the number that we obtained, which is 8, and that's going to equal the exponent of 3. So 2 cubed equals 8 converts to log base 2 of 8 equals 3. In part B, we have 5 squared equals 25. We have a base of 5, an exponent of 2, and that is equal to the number 25. Converting to logarithmic form, we take the log base 5, the base of our exponential, evaluated at our value of 25, and that's going to equal the exponent of 2. So 5 squared equals 25 is equivalent to log base 5 of 25 equaling 2. And last but not least, part C, we have 10 to the negative 4th power equals the fraction 1 over 10,000. So here we have a base of the exponential of 10, we have an exponent of negative 4, and we have that equaling a value of 1 over 10,000. When we use the equivalency from earlier to convert this, we see that we get the log base 10, the base of the exponential, evaluated at our value of 1 over 10,000, and that's going to equal our exponent, which is negative 4. So here we get the log base 10 of the number 1 over 10,000 equaling negative 4. If you'd like some additional practice converting between exponential and logarithmic forms, you can try these problems here. You can pause the video, try them on your own, and in a few seconds, the answers will appear.